Zaynidin aka, navbat sizga.
Hop, bo'lmasa endi boshlaymiz. Qani, bismillahirrohmanirrohim. Assalomu alaykum va rahmatullohi va barakatuh. Very good evening. So now let me present my usual seminar. Okay. So can everybody see? Can everybody see my notes? Please reply.
Ko'rinyapti. Bemalol.
Okay. So, okay, I directly will start from Adamian decomposition method. Okay, so far we have learned many other type of method. Now this method is called semi-analytical method, which means by using this method, we can find exact solution or approximate solution. So actually Adamian is a scientist in one actually. So this is the author of the method developed so-called Adamian decomposition method, or simply decomposition method. Usually we say ADM. Shortly we always say ADM. So this method was well introduced by Adamian in his recent book. Actually, he wrote a book also, and the method proved to be reliable and effective for the wide class of equations, especially differential and integral equation, including PDE, partial differential equations. The method was applied mostly to ordinary and partial differential equations. But here says that for the integral equation is less used, but after writing the book of this this is Malignejad. So actually, one moment, the author of the book is who? Malignejad, or so just in the beginning of Abdul Majid, I think Abdul Majid. This is Abdul Majid Vazvaz. Actually, Abdul Majid Vazvaz is one of the famous researcher in the area of integral equations and integral differential equations, linear and nonlinear. He has published many high quality journal publications, and he at the end wrote a very simple but very valuable book. Okay, so this is we are learning his book actually. Now, what does it mean, decomposition method, Adamian decomposition method? Actually, as we have seen in the previous my lecture, I have shown iteration method. Actually, this is a, we can say, development of the iteration method. But this simple development brings a lot of changes and very convenient tools to open the problem or solve the problem. For example, to solve the integral equation. Now let me write down our main equation, because here just application. I will write as usual. I put on the left side my lecture book, and on the right side my whiteboard. Okay, where is my whiteboard? Here. Okay. So little bit I do like this, and this one I make a little bit smaller to see this. Okay, so now our equation, actually he applied mostly for integral equation of the second kind. Actually for the first kind also can apply, but at the moment let us we use what happened, why my okay. Okay, now the our equation. So little, okay, now you can easily see. So today is ADM. We are learning ADM. ADM. What happened? think something wrong with my pen today. What happened? Huh? Why doesn't move well? Okay, ADM, adamant decomposition method. So our main equation, actually here in the Canval, usually we denoted G of T, but here we denoted the unknown function as U of X. It is better to follow the same parameters because not to confuse. Integral from A to B, kxt U of T dt. So this is the equation 1. And this is called the Freedom integral equation of the second kind. Okay. Now, to solve this equation 1, what the Adamian did, so he just searched the solution in the form of the series. Okay. This is, I'm just repeating because previously we started, but never mind because today we have many new the participants. So we just search solution in the series form, n from 0 to infinity un of x. Then later on, I will show you that more development, more perfect, more better method, call it homotopy analysis method. So at the moment, this is the beginning part of the semi-analytical method. So just this is the equation number 2, and substitute into the equation 1 on the left side. We have u n of x n from 0. Actually, it is better to write immediately this one by expanding, because in order to find the recurrent relations, better to write, you see, by substituting and at the same time opening. On the left side, I have u0 of x plus u1 of x plus u2 of x plus and etc. equal f of x plus lambda, because this is the linear equation. So instead of this one, when we substitute it and open up it, we will have the following following form: from A to B, kxt u0 of t plus lambda integral from A to B, kxt u1 of t dt. Sorry, here dt also. So dt plus and etc. This infinitely. So by equating both sides, usually as an initial guess, we choose u of 0 for this particular integral equations. Usually we choose the given function f of x. So u1 of x on the left side equal to lambda integral from A to B, kxt u0. So actually, if I put this one, at the moment, I just put 0 of t dt because to see the trend. So this is u1, u2 is the same. Generally, I can say general term uk, for example, uk of x is equal to lambda from A to B, kxt uk minus 1, the previous term. Actually, in the iteration method, we have only this, right? UK in terms of UK minus 1. And U0 is just an initial guess. So if we choose initial guess like this, actually here we can generate it. Now, difference is that, so here when we find the U0, U1, U2, and UK, we substitute this value into the 2 and get the series solution. An interesting point, most of the time, by choosing this U0, properly choosing the U0, we can get exact solution. Actually, currently, this is the scheme. This is the scheme. Now, at the same time, I give the modified Adam decomposition method. Then you will see the differences of modified and the standard, and what is the benefit of the modified. Here, of course, Malik Najat explained it in the example. And of course, in the paper, I have seen that there is a theoretical improvement or theoretical proof that the decomposition method is better than the standard one. So, okay, let me just show immediately the decomposition, the Adam decomposition method, modified one. So in the modified one, then we will just apply for the examples. Okay, I just leave it like this. Now, let me show you the modified one. Okay, in the modified one, so we have the same equation. I just show the main equation here. So our main equation is here. Okay, this is equation 1. So here, what I do,